Okay, let me ask you something honestly. Have you ever worked with a CSV file and suddenly Pandas becomes slow? Your system starts lagging, or worse, your notebook just crashes, and you're like, why is this happening? So, for that question, this video answer the exact way. Okay, welcome to Pandas Advanced Part 4. In this video, we are not learning new fancy functions. We are learning how to control memory, understand data types, and make Pandas behave like a professional tool. And most Pandas tutorials ignore this part. They show you group by, charts, filters. But in real life, data is messy, large, and heavy. If you don't understand memory and data types, even correct code can fail. Okay, so now I created a dataset that we previously worked with. I just added the age to this, okay, because we are working with it, and run. Then we get everything. So whenever I open a new dataset, this is the first line I should run. That's df.info. Okay, this method tells me how many rows I have, what data types Pandas guessed, and how much memory and dataset is using. Here we can understand how much memory usage this dataset is using here. This is where professional analysis starts. Here is a common mistake. Pandas often reads numbers as objects instead of numerical types. That means more memory, slower operations, unnecessary problems later on. Okay, so we fix that. How? Fixing that by changing its types. We are using as types. We already use as type, and here we are using this to change the age to an integer form. Okay, let's just go through this. Here, the age is already in integer form, but if it was in a float or it was just as a offset, we need to change it into integer. For that, I'm starting this with df age and df age dot as type. We are giving int 64 in quotations. Don't forget the quotation marks. Afterwards, we are using df salary and equals df salary. We are using again dot as type with int 64. Okay, so now we gave this in integer form. Okay, you can see here everything was already in a float form. I mean integer form. So I just move this sum of it to float, and let's run this. Again, you can run it here. So now the salary changed to float form. And here there is age. We can also change the age to, I can add quotations here. So it will change to object. Okay, now run. Now the age is changed to object. So as you can see here, we just manipulated our data set to get a messy data. Okay, and afterwards I'm going to run this. And by explicitly setting the data type, we are telling Pandas exactly how to store the data. Less memory, faster operations, more control. Now I just changed its data types and use quotations and float within our data set. But in real data, the data is really messy. It will be much more messier than this. In such cases, we explicitly use this as type to convert the data types to integer form. So it can improve the storage, faster operations, and get more control over this. Okay, now we can add category data types, which is a hidden power. Okay, for that I am adding df department and equals, we are adding df department and then dot as type category. Okay, and run. This line is extremely powerful. For columns with repeated text like departments, countries, or roles, category can reduce memory usage drastically. If we are working with a smaller data, but this can be applicable to larger data with millions of columns and rows. Okay, so this is a basic logic that can be used anywhere in our data set. Okay, this is the one of those small changes that makes a huge difference. Now we are going to check the memory again. Okay, let's do df.info again. So now we can see this. The department is in category. The age changes to integer form. Salary changes to integer form. Okay, always recheck after optimizing a code. Okay, I mean a dataset. This is how analysts validate improvements, not guess. Okay, look above. You can find all this. He was the department was in object, and age was in object, salary was in float, and everything just got changed. Now everything was set. The department changed to the category, age changed to integer, and salary changed to also integer form because we used s type here. And advanced pandas is not about writing more codes. It's about asking, do I really need this data type? Is this column optimized? Or will this scale to bigger data? So all these questions should be asked by an analyst. This mindset is what separates tutorials from real work. So in this part, we learned how to control memory instead of fighting it. In next video, we will take this optimized data and use it for ranking, prioritization, and decision-focused analysis. That's where pandas start answering real business questions. Okay? So the thing is, if you don't control data types, your data controls you. So we need to control the data types. Before concluding this session, I would like to ask, why do we convert to category? So for that question, it's like, okay, you might be thinking, it's just converting because we need to get a lower memory storage. Yeah, that's the answer. But that is more than that. Okay, let me explain this in a simple way. Okay, so imagine you have a company with 10,000 employees, and the department columns contains like HR, IT, finance, and repeating HR, IT, HR. It's repeated again and again. If Panda stores this as normal text, it stores the full word every single times. So, do it really need it? I guess no, because that's waste memory. Okay, so when we convert a column to category, Pandas becomes smart. Instead of storing the word HR 1,000 times, it stores one master list HR, IT, finance, and then just stores small codes pointing to them. Like same data, much less memory. Okay, so the code we used here, department with S type category, this single line tells pandas, hey, this column has limited repeated values. Optimize it. Okay. So uh, we are not saving the HR. If there are 1,000 HR, we are not saving the 1,000 as HR. We are just pointing it out under this. Okay. So for small data sets, you won't notice much difference. But for large CSV files, this can reduce memory usage a lot and making operations faster. So that's why analysts always convert columns like department, country, gender, status into category because they are repeated values that can be found in large CSV files. So use category when values repeated a lot, when the column is descriptive text, or when you are grouping or filtering on it often. Okay, don't use category for free text, unique IDs, constantly changing values, all these situations. So, category stores repeated text efficiently and saves memory, but not the text which can have unique values or changing values. Okay, so by converting important text columns to category, we make pandas lighter, faster, and more professional. Okay, so That's why we use category here. So now you can understand why we use the category for department, because there are many HR which is repeated values. It can be it don't want to save under HR every time, like it don't want to use HR, but we used to put it as a category. So it will remove the storage and it will reduce the storage, make the operation much more faster. So because of this is a small data set, we don't understand what's really happening. But while working with large data sets, you can understand why it is used and what is its importance. Okay, so that's all for today, and see you in the next part soon. I want to give some more clarity to the category, that how it is really stored internally. So I'm just taking this part, okay, and this is how our list look like. While there are repeated values, HR is repeating, IT is repeating. So now Pandas replaces this text with numbers. Like here, HR will be calculated as 1 and IT as 2 and finance as 3. Okay, so these numbers are not just values themselves. They are just referring to the category list, as we see here. And they are just a reference to each of the categories. And Pandas uses numbers because numbers are faster and lighter than text. So codes are indexes pointing to category values, not new data. Okay, so that's it. That's what it exactly happens internally. So I want you to be clear with the word category and how it used in Pandas. Okay, so have a great day. Bye.